Okay, children. Now let us find the trigonometric functions for the angles which are not actually the angles of first quadrant. They may be coinciding with the angles of first quadrant or second or third or fourth quadrant. See this one. It is sine 765 degrees. So I am going to break 765 degrees as a sum of an acute angle and the remaining part. So you will see 765 can be written as 720 plus 45 degree. Let us see where is this 720 degree angles. First, when we start evaluating the angle, we complete one revolution, we get an angle of 360 degree. And this, if we proceed again, another revolution if we take, it comes out to be 720. So 360 plus 360. So twice when I complete the revolution, we get angle 720 degree, and you will see 720 coincides with 360, which further coincides with 0 degree. So whatever is sine 0 degree, same will be sine 360 degree, same will be sine 720 degrees. So we can replace 720 degree with 0 degree because it is coinciding with that angle. So our angle is reduced to a smaller one. So now it is sine 0 degree plus 45 degree. Now 0 plus 45 is 45 only, and sine 45 we can very well define it as 1 over root 2. Then see the next one, cosec minus 1410. Okay, we know that cosec minus theta is minus cosec theta. So keeping this in mind, we can first write it as minus cosec 1410 degrees. Again, we'll try to break 1410 degrees into sum of two or difference of two angles. You have to keep in mind the second one has to be an acute angle, and try to break it in such a way so that your this angle, either it coincides with 360 degree or it coincides with 180 degree. So you will see, look at this one, 720. If I take double of 720, it will become 1440. So that means we complete one revolution, we get 360, we complete another revolution, we get 720, we complete one more revolution, it will be 720 plus 360, then go for one more revolution, you will see it comes out to be 1440 degrees. So 1410 degree can be written as 1440 minus 30. Okay. And this 1440 degree is again coinciding with 0 degree. So we can replace it by 0 degree, and what do we have now? Minus cosec 0 degree minus 30 degree. Now 0 minus 30 will be minus 30 only. Again use cosec minus theta is minus cosec theta. So this minus sign can be taken out. Already you are having a negative sign here. So minus of cosec 30 becomes cosec 30 degree, which will come out to be 2. Sin 30 degree is 1 by 2. So cosec 30 degree is 2. Now here the angle is given in radians. Tan 19 pi by 3. See how will you break it into a simpler form. Whenever you do so, you look at this number and try to break it into two parts such that one part is a closest multiple of 3. That is the denominator. Now which number is very close to 19, which is a multiple of 3? We know that 19 can be written as 18 plus 1. 3 into 6 is 18. That is the closest multiple of 3 to 19. So I will break 19 pi as 18 pi plus pi. Then you take the denominator separately with both. So 18 pi over 3 will become 6 pi, and this will be pi by 3. Now let us try to find out 6 pi is coinciding with which angle. Now I'll measure the angles in terms of pi. Okay, this is 0. When we complete one revolution, we get 2 pi. When we complete one more revolution, 2 pi will get added to it. So 2 pi plus 2 pi is 4 pi. Then you take one more revolution, it will become 4 pi plus 2 pi, which is 6 pi. So you will find 6 pi is again coinciding with 0 radians. This time we'll call it 0 radians because we are measuring angles in radians. So 6 pi coincides with 0 radians. Okay, so you can replace 6 pi by 0. That means the function is now tan 0 plus pi by 3. Now 0 plus pi by 3 is pi by 3 only, and the expression now reduces to tan pi by 3. Pi by 3 radians is 60 degree. So tan 60 degree you all are aware of, it is root 3. So the value is root 3. Fine. Then quickly taking the next two. This is sine minus 11 pi by 3. See again, sine minus theta is minus sine theta. So I will take out the negative sign here. And it is sine 11 pi by 3. Now as I told you in the previous one, please look for the closest multiple of 3 to 11. Which number is very close to 11 and it is a multiple of 3. You will find it is 12. So 11 can be written as 12 minus 1. Okay. So 11 pi is mentioned as 12 pi minus pi. Now you divide both of them by 3 separately. We get minus sign. 12 pi over 3 becomes 4 pi. And this is minus pi by 3. So now you need to check which angle 4 pi will coincide with. Okay. See, when we complete one revolution, it is 2 pi. Second time when you will complete the revolution, it will become 4 pi. So 4 pi is going to coincide with 0 radian. All the even multiples of pi, they will coincide with 0. See, after one revolution, 2 pi, then 4 pi, then 6 pi, then 8 pi. So every odd multiple is, even multiple is coinciding with 0 radian. Odd multiples will coincide with pi radians. Okay. So 4 pi is coinciding with 0 radians. So this becomes now 0 minus pi by 3, which is minus pi by 3. Again use sine minus theta is minus sine theta. We can take out this minus sign and we are just left with sine pi by 3, which is root 3 by 2. Now 10th one is of the same type. See, it is in the form cot minus theta. We can write it as minus cot theta. Then breaking it into two parts, the closest multiple of 4 to 15 is 16. So 15 pi can be written as 16 pi minus pi. And dividing both with 4, we get this as 4 pi and this becomes pi by 4. As explained in the previous one, 4 pi is coinciding with 0 radians. So you can replace it by 0. And your question is now minus cot of minus pi by 4. Again, see, as cot minus theta is minus cot theta, you can take this minus sign outside and it is now, see the simpler form of this. Same question, trigonometric function, but in simplified form, it is cot pi by 4. Pi by 4 is 45 degree and cot 45 degree is 1. So cot pi by 4 is equal to 1. So you can see, understanding the concept of sign of trigonometric functions in various quadrants and their behavior, we are able to simplify the trigonometric functions for larger angles as well.